Good day to everyone. My name is Ivana Costa Cosmiño, and today I'm going to share with you the work that I've been doing in the Energy and Climate Change Research Group at Tecnológico de Monterrey. Worldwide energy demand continues to increase at a constant pace. In 2018, 81% of the world's energy was produced by fossil fuels. According to the US Energy Information Administration, by 2040, the worldwide final energy consumption will increase by 48%. The growth rate results particularly higher in developing countries due to the rapid rate of industrialization of manufacturing sectors in most of them. Moreover, the higher energy intensity and the lesser clean energy matrix jeopardize worldwide sustainable development. Industry accounts for 78% of global greenhouse gas emissions. From 1970 to 2010, making this a relevant sector where energy production strategies should be implemented to mitigate climate change. In Mexico, the industry is the second largest final energy consumer sector, just after transportation, accounting for almost 32% of the energy demand. The industrial sector uses electricity for operating industrial motors and machinery, lights, computers, and office equipment, and equipment for facility heating, cooling, and ventilation. Moreover, the industry uses fossil fuel sources for heating industrial processes and space heating in buildings, and to generate steam or hot water for process heating. Despite that electricity is the most socialized and known form of energy, thermal energy demand in the industry is higher than electricity. About 3/4 of the industrial final energy demand is consumed in terms of heat, which is mainly produced by fossil fuels. This is not different in Mexico, where thermal energy accounts for 64% of the industrial final energy demand. About 30% of the heat demand is consumed at a temperature below 150 degrees Celsius to drive processes like boiling, pasteurization, drying, cleaning, sterilization, among others. This temperature can be efficiently produced by solar collectors, like heat pipes, parabolic troughs, or linear Fresnel. Hybrid solar collectors, or PVT, are capable of simultaneously producing heat and electricity. This technology allows us to have a more efficient conversion of the available solar resource by recovering the heat that is not produced into electricity by the photovoltaic cells. Commercially available PVT collectors, like the one in the top of the slide, generally consist of a photovoltaic panel that has a duct or piping array in the back to recover the heat with the flow of water or air. Nevertheless, the heat temperature reaches a maximum of 50 degrees Celsius, which is useful mainly for residential applications. LCPVT, which stands for Low Concentrating Photovoltaic Thermal Collectors, it's a technology usually based in low concentrating geometries like Parabolic Trough. The LCPVT collector in the figure at the bottom of the slide is a technology that has been developed in our research group, which consists of a triangular duct located in the focal point of the linear parabola. The duct has monocrystalline solar cells attached to the sides of that receive concentrated solar radiation. Heat is recovered by water that flows inside the duct. This LCPVT collector is capable of producing water at 70 degrees Celsius, maintaining an efficient production of electricity. The food and beverage industry is one of the sectors with the greatest potential to incorporate solar thermal and hence LCPVT technologies, mainly due to the low temperature processes involved in manufacturing. According to the available reported data in Mexico, the food and beverage industry consists of beer, soft drinks, ice, and tobacco production. In Mexico, this sector accounts for nearly 5% of the industrial final energy consumption, considering the sugar production sector. From 38 petajoules consumed by the sector, 78.2% account for thermal energy that mainly comes from fossil fuels, with which combustion produces greenhouse gas emissions. Mexico is responsible for nearly 1% of the global CO2 emissions. In 2015, this country emitted 683 million tons of CO2, which is equivalent to the emissions of 150 million cars in 1 year. The manufacturing industry accounts for 9.3% of the national greenhouse gas emissions, and in 2015, the food and beverage sector emitted 1.64 million tons of CO2 equivalent. For the Paris Agreement, Mexico committed to reducing by 2030 22% of the greenhouse gas emissions, compared to those issued in year 2000, which were about 530 million tons of CO2 equivalent. This target includes sectorial detail, where one of the pledges is to reduce 5% of the greenhouse gas emissions in the industrial sector by 2030. Many studies presented in the literature deals with a prospective analysis of different strategies to reduce energy demand or to clean the energy matrix. These studies mainly focus on developing countries due to the increasing energy demand provoked by the industrial development. Some of the technologies that have been studied are solar water heating, power generation technologies such as nuclear, natural gas, and photovoltaics, electric vehicles, and the deployment of innovative technologies like the one we propose for this study. Hybrid LCPVT collectors can produce simultaneously electricity and heat at temperature levels useful for industrial processes. The research question that we are planning to answer is, can LCPVT technology support the decarbonization of the food and beverage sector in Mexico? The objective is to develop a prospective analysis of the impact in the reduction of greenhouse emissions that the deployment of LCPVT technology may achieve in the food and beverage industry in Mexico from now to 2030. The study consists of a top-down complemented by a bottom-up approach to compensate for the lack of data required for a bottom-up detailed analysis. The research starts with a historical analysis of the energy demand, fuel intensity, and the gross domestic product of the sector in Mexico. This will allow determining the correlation between the economic development and sectoral final energy demand, as well as establishing the economical and technological scenarios to study. Finally, the energy perspective modeling is performed using the software LEAP. In this study, the gross domestic product was selected as the exogenous variable to correlate with the final energy demand. This macroeconomic variable has been widely used in the literature to predict the final energy demand. The GDP in Mexico has been increasing with an average of 2.68% per year. Nevertheless, according to national available data, in 2019, the Mexican economy presented stagnation, which means no economic growth. The historical analysis of the final energy consumption of the proposed sector is a key part of the prospective study. It allows us to establish assumptions and scenarios for the study. In this graph, the historical fuel share of the food and beverage sector is presented. Electricity and natural gas share have increased during the last decade. In contrast, fuel oil share has almost been eradicated since 2017. What is shocking about this graph is the absence of renewable energy sources in the energy matrix. To have a reference, in the food processing industry in the USA, about 4 to 8% of the energy demand is covered with renewable energy sources. The scenarios analyzed in this study were established considering two approaches. The first one is related to the economical growth of Mexico, and the second one considers the level of deployment of the hybrid LCPVT technology. Positive and negative growth scenarios. Positive and negative growth scenarios were established with an annual growth rate of GDP of positive 2% and negative 2% respectively, from 2023 to 2030. From 2020 until 2022, the economical recession caused by COVID-19 pandemic was considered. Three technological scenarios were established: business as usual, BAU, medium technology deployment, MTD, and large technology deployment, LTD. The first one is characterized by increasing the share of natural gas and electricity and slow penetration of solar technologies. In the MTD and LTD scenarios, LCPVT participation in thermal energy demand is considered to achieve 11% and 28% respectively, displacing the share of natural gas, LPG, diesel, and fuel oil. LEAP software was selected to model the final energy demand and the greenhouse gas emission of the sector. Long-range energy alternatives planning system is an integrated software tool used to perform energy policy analysis, which is widely used for the energy policy planning, climate change assessment, and cost analysis in a defined period. It is done by designing scenarios where each one has its specific information. All these characteristics allow developing a demand energy analysis based on demographic and macroeconomic data of the study area, like the gross domestic product. The energy demand is calculated as the product of the total activity level and the energy intensity at each given technology branch. Energy demand is calculated for the current account year and future years in each scenario. Current account is the starting data for all scenarios. In this study, it corresponds to the year 2018. Regarding the analysis for the atmospheric polluting, the use method for emissions is per consumed energy unit for each fuel source. This is based on the technology and environmental database, TED. TED includes polluting emission factors proposed by the IPCC, where the polluting emissions are classified by default and hierarchical from according to the energy demand. Regarding the final energy demand of the food and beverage sector, in the negative GDP's growth scenario, in 2030, the energy demand will be down to 29.27 petajoules in comparison to 37.48 petajoules in 2018, which is about 21.9% less. While in the positive growth scenario in 2030, the energy demand will increase to 39.98 petajoules, which is 6.7% more in comparison to 2018. In the figures presented in this slide, we can observe the evolution of the share of every fuel in 2020, 2025, and 2030. The heat generated by LCPVT technology displaces natural gas, fuel oil, LPG, and diesel in the MTD and LTD scenario. Natural gas and electricity become the principal energy sources of the sector in the business as usual scenario. In the current account setup, 78% of the final energy demand is consumed in form of heat. Natural gas and diesels are the most consumed fossil fuels for the heat generation. Moreover, fuel oil has almost no presence in the food and beverage sector energy matrix. The energy demand projection in 2030 for the medium technology deployment scenario results in a 9.35% participation of the LCPVT technology, where 5.2% of the electricity demand will be covered by the hybrid collectors, as well as 11.2% of the heat consumption of the food and beverage sector. For the large technology deployment scenario, 22.36% of the final energy demand of the sector could be provided by the LCPVT solar technology. 12.8% of the electricity consumption and 28% of the heat demand could be produced by the proposed technology. Regarding the analysis of the impact on greenhouse gas emissions, in 2018, the food and beverage sector emitted 1.76 million tons of CO2 equivalent. For the business as usual scenario, 1.15 and 1.58 million tons of CO2 will be emitted in 2030 for the negative and positive economic growth scenario, respectively. For the MTD scenario, the greenhouse gas emission level could achieve 1.02 and 1.53 million tons of CO2 equivalent in the negative and positive economic growth scenario, respectively. Finally, the LTD scenario. For the LTD scenario, the pollutant emissions reach 0.85 and 1.16 million tons of CO2 equivalent in the negative and positive economic growth scenario. One important finding of this study is that for the MTD and LTD scenario, the decoupling of the greenhouse gas emission from the energy demand profile is achieved, which is a desirable behavior that is presented in developing countries' industrial sector. In contrast, within the BAU scenario, after the economic recession, greenhouse gas emission continued to rise as the energy demand increased. The conclusions that we can share about the study are the following. In 2030, the energy demand in the food and beverage sector could be 29.27 petajoules and 39.98 petajoules for the negative and positive economic growth, respectively. Heat demand in this sector will decrease from 78% in 2018 to 69% in 2030. This is mainly achieved by the electrification of processes trend in this sector. LCPVT technology could produce 23.36% of the final energy demand in the LTD scenario. 1.56 petajoules of electricity and 7.78 petajoules of heat. In the medium technology deployment scenario, 9.35% of the final energy demand is generated with LCPVT collectors, 1.14 petajoules of electricity and 5.70 petajoules of heat. Electricity and natural gas share in the final energy demand continue to increase, in contrast with diesel, LPG, and fuel oil, whose share decreases in all scenarios. Due to COVID-19 recession, all the scenarios, economical and technological, achieve a reduction in greenhouse gas emissions in comparison with 2018. Business as usual scenario is the only one that presented an increasing greenhouse gas emission profile post-recession. MTD and LTD scenarios reduced greenhouse gas emissions by 18.8% and 34.1% respectively in comparison with 2018 emissions. The coupling of energy consumption and greenhouse gas emission profile is achieved by MTD and LTD scenarios, being the last one the most representative one. LCPVT technologies produce thermal energy at temperature level useful for industrial processes in comparison with PVT. LEAP is a powerful tool to assess the different strategies to reduce greenhouse gas emissions from the energy perspective. This study should further be extended to validate the LCPVT production, considering available solar resources, available land for installation of technologies, and heat consumption by region. Moreover, the evaluation of the impact in other sectors such as mining, pulp and paper production, chemical industry, among others, is recommended. Thank you everyone for watching, and I'm looking forward to the discussion group to answer all the questions that you may have.